Hello friends, we're going to continue on talking about trigonometry today. We're going to be solving for a side. Our learning target, I can use sine, cosine, and tangent to solve for missing sides of a right triangle. You can see our state standard here. Recall, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Remember, those are all sides of the right triangle. Our acronym, SO, sine opposite over hypotenuse. CA, cosine adjacent over hypotenuse. TOA, tangent opposite over adjacent. So grab whatever calculator you're using. You need to make sure that it's in degrees, not radians. Different calculators have different ways to switch between degrees and radians. So your best bet is to just Google whatever calculator you're using or whatever you're using for a calculator and ask, how do you switch it from degrees to radians? Whether it's on your phone, on your iPad, a graphing calculator, a scientific calculator, they all have different ways of switching back and forth. On whatever calculator you're using, if you do sine of 30, you should get 0.5. If you did not get 0.5, so you just hit the sine button and then 30. If you did not get 0.5, then your calculator is probably in radians and not degrees. Also, depending on what calculator you're using, sometimes you need to put the degree in first and then hit the sine button. So you'll have to kind of play with it and see what the order is. Cosine of 75, if we round it to the nearest hundredth, you should get 0.26. And tangent of 45 equals 1. As we're solving for sides here, the first thing we do is circle our reference angle. So here my reference angle is 54. So from 54, I'm going to say that 20 is the hypotenuse. This blank side is my opposite, and x is my adjacent. Because I'm looking for my adjacent side and they're giving me my hypotenuse, that means I'm going to be using cosine, adjacent and hypotenuse. So I know that cosine of 54 equals adjacent, which is x, over hypotenuse, which is 20. Now we need to solve this for x. In order to solve it for x, I need to get rid of that 20. The opposite of dividing by 20 is multiplying by 20. So I'm going to multiply both sides by 20. And then 20 times the cosine of 54 equals x. So you're going to put this in your calculator. Again, depending on what kind of calculator you're using, the order might change. So you might have to find the cosine of 54 first and then multiply by 20. If you're using one of the graphing calculators, you can just put it in as 20 times cosine 54. We're going to round to the nearest hundredth, which means x is approximately in this case, 11.76. If you got anything other than 11.76, make sure your calculator is in degrees. And again, you might have to play around with this order. Let's look at another one here. Here my reference angle is 28. X is my hypotenuse. 45 is my opposite. And this blank side is my adjacent. We're looking for the hypotenuse and we're given the opposite. So we're going to be using sine because that deals with opposite and hypotenuse. Sine of 28 equals opposite, which is 45, divided by hypotenuse, which is x. This one takes a few more steps to get x by itself. First thing we need to do is get x out of the denominator. So I'm going to start by multiplying both sides by x. And then I get x times the sine of 28 equals 45. So to get x by itself, I'm going to divide by the sine of 28. Which then means x equals 45 divided by the sine of 28. If you put that in your calculator, 45 divided by sine 28, and we round it to the nearest hundredth, we'll get 95.85 approximately, because we're rounding. So get another one here. My reference angle is 63. Here is my hypotenuse. I know that because it's across from the right angle. 17 is my opposite. X is my adjacent. I'm looking for the adjacent and I'm given the opposite. So O and A means I'm using tangent. So I know tangent of 63 is opposite, which is 17, divided by adjacent, which is X. Again, when X is on the bottom, like the previous example, it's a few more steps to get X by itself. So we're going to start by multiplying both sides by X. And then I get X times the tangent of 63 equals 17. And then to get X by itself here, we'll divide by tangent of 63. So X equals 17 divided by tangent of 63. And if you put that in your calculator and round to the nearest hundredth, we would get about 8.66. Let's look at another one here. Our reference angle is this 20 degrees. This 20 is our hypotenuse. The blank side is opposite, and X is our adjacent side. It looks like we know the hypotenuse, and we're looking for adjacent, so we're using cosine. So cosine of 20 equals adjacent, which is X, divided by hypotenuse, which is 20. To get X by itself here, we'll just multiply both sides by 20. So 20 times cosine of 20 is X. And if you put that in your calculator, we would get that X is approximately 18.79 if we're rounding to the nearest hundredth. So get another one here. My reference angle is this 26. I know X is my hypotenuse, 19 is my opposite, and this blank side is my adjacent. I'm looking for the hypotenuse. I'm given the opposite, which means I'm using sine. So sine of 26 equals opposite, which is 19, over hypotenuse, which is X. So to get X alone, first I need to get it out of the denominator by multiplying both sides. And I get X times sine of 26 degrees equals 19. And then to get X by itself, we'll divide by sine of 26, which means X is 19 divided by sine of 26. And if you put that in your calculator, you would get 43.34 if we're rounding to the nearest hundredth. Let's look at a word problem here. We're still going to do it the same way. Anton is building a bike ramp that rises at 25 degrees and will rise 4 feet off the ground. Determine the length of the ramp. So our reference angle is 25. X is our hypotenuse. 4 feet is our opposite. The bottom here is our adjacent. We're looking for the hypotenuse. We know the opposite, so we'll be using sine. So sine of 25 degrees equals our opposite, which is 4, divided by our hypotenuse, which is x. To solve this, we'll start by multiplying both sides by x. So x times sine of 25 equals 4. And then dividing both sides by sine of 25. I would get that x is 4 divided by sine of 25. If you put that in your calculator and then rounded, you would get about 9.46. So our final answer is 9.46 feet. Make sure you're labeling. Remember, if there's labels in the question, there should be labels in your answer. So get one more. A plane takes off and climbs at a 12-degree angle. Is that angle sufficient enough to fly over an 11,088-foot mountain that is 12.5 miles from the runway, or does the plane need to increase its angle of descent? You should know that 11,088 feet is equal to 2.1 miles. So our answer then needs to be bigger than 2.1 if they're going to be able to make it over that mountain. So let's look here. Our reference angle is 12. That's our hypotenuse. Opposite is x. Adjacent is 12.5. So we're using opposite and adjacent, which means we're using tangent. So tangent of 12 equals opposite, which is x, over adjacent, which is 12.5. So solving this one, we just need to multiply both sides by 12.5. So 12.5 times tangent of 12 equals x. If you put that in your calculator, you would get that x is approximately 2.66. So that means the plane could fly over something that is 2.66 miles high. And this mountain that they're talking about is only 2.1 miles high. So yes, the plane can fly over the mountain. All right, friends. That's all I have for you today. Remember these steps. You're going to want to follow these steps for all of your problems. All right, have a nice day.